Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
Aww. That's so cute. Hi, I'm Dr. Moiya McTier. I'm an astrophysicist and a folklorist, and I am a friend to the universe. I got invited to its birthday party next millennium. I can't go.
God.
I'll be dead, but
Yeah, darn.
I was invited.
If only, are they free tonight?
Well, you know, we are the universe, so are we free tonight? That's the real question.
I'm going to see my nephews tonight.
Oh, good.
I'm really excited.
Oh, good.
And I'm Corinne. I'm Corinne Caputo.
Yeah, I was like, who are you?
Who am I? Writer, funny person, and friend to the universe.
Yay.
And I'm so excited about where we are today.
Where are we?
Because
Yeah.
speaking of my nephews, we are in an Italian restaurant. And I say that because I'm from Staten Island, so there is a extremely cozy aspect to an Italian-American restaurant. They all have the same menu, and yet they're all completely different.
So different. You're right. Yeah, like the sauce.
Yes.
I know that the sauce is going to be different at different restaurants.
Yeah, and boy, is it scary when you, like, try the red sauce at a new place, because you're like, what's this going to be?
So this is a restaurant that you grew up going to?
You know, I'm debating whether I say the name, because I'm not sure I morally align with a lot of these places.
That's fair, but you know this red sauce.
Yes. And it is
Okay.
cozy and comforting to me. And, you know, I just found out they do ship it frozen to your house. So I got it for my birthday last year from my brother. Very cute.
Oh,
So I'm
your
going to
twin
have to do
brother.
that again. Yeah. The famous twin.
The famous twin. Actually, I think we decided that he was the infamous one a few episodes ago.
You're so right. I got to write that down.
Well, I might ask for your advice, your recommendations when it's time to order. But we are here in this corner booth in the restaurant.
Thankfully.
To talk about, you know, where it's a little bit quieter. We don't have to worry about people interrupting us because everyone knows us and they keep asking us the space questions.
Exactly. And I didn't take us to the other Italian restaurant where they randomly, like, cling a glass and everyone, like, you know, kind of lassos their white napkin around their head. I don't know why.
What?
I'll have to ask the community about that one because I really don't know why we do that. I guess it's fun.
I guess so. Wow. Okay, yeah, glad we're not going to have to be dealing with that while we're talking about today's topic, which is moon formation.
The moon. I
The moon.
love the moon.
How do you feel about other moons besides ours?
I think they can join the club.
Cool.
They can definitely
Cool.
join the club. I have such an affinity for the moon that I get to see all the time, so obviously that's my favorite moon.
Obviously. And we have decided that the moon, our moon, Earth's moon, is for the people.
Yes.
So what's not to love?
Exactly. It's I can't think of a single word to describe it, but it's so beautiful and I love it.
So yeah, in this episode, I want to talk about how scientists think our moon formed. I want to talk a bit about other moons in the solar system. I want to talk about rings around planets.
Yes.
And then eventually I want to talk about the search for moons around planets around other stars. These are called exomoons.
Ooh.
Yes. So that's very exciting. And if you listeners make it to the end of the episode, which I highly recommend, not
hope
just
you
for
do.
this one, but for all of our episodes,
hope
you
you
should
do.
listen to the end.
We reveal a secret at the end of every episode.
We're going the Ali Ward route. You know, Corinne, I've been thinking about our Moonfall review.
Uh-huh.
I've been thinking about the Moonfall movie, and if you stay to the end, you will hear my hypothesis for where the extra mass for the moon came from in Moonfall. I think I figured it out.
Okay, I'm glad you said that because I also came up with a fun game, and Moonfall might make an appearance in it.
Oh, good. It's all coming together.
Moonfall is canon to us, unfortunately.
Yes. Moonfall, the movie that got 5 out of 15 moons. We did not like that movie, but we are going to continue to talk about it.
We should watch it once a year, I think, and revisit our review.
That would be such a sad tradition.
It's kind of a curse.
You're right.
Also, years come up pretty quick. We're going to be watching it. It's going to feel like we're watching that movie all the time.
No, but like every 50 episodes, it's going to be another Moonfall review. Oh, God, hopefully not. So I want to start this with a rundown on planet formation, a review of planet formation. We've talked about this before, but I want to make sure it's fresh in everyone's minds. Although, Corinne, can you tell me what you remember about how planets form?
Okay, this is really going to show my attention disorder, but so, okay, there are these things that, like, are orbiting a star.
Uh-huh.
I'm forgetting the definition of a planet. So a planet, it's like a rock, right?
Okay, let's start a little bit earlier. How does the star form? What does it come from?
God. No, actually, yeah.
From now on, this podcast, when we ask a question at the beginning, how does this space thing work? Corinne says God, and then the episode's over.
And that's it. And that's really what a podcast should be.
Okay, no, I'll take you out of the hot seat, and I'll do this review of planet formation processes. So what we start with is a big cloud of gas. That gas will have different types of molecules in it. There's going to be a lot of hydrogen. There might be some heavier elements that were produced in the cores of now dead stars. But eventually that cloud of gas is going to cool down. It's going to contract, and it will get these little clumps of denser material in it. Those clumps will turn into stars. So you have a baby little star in the middle. It probably has another stellar companion around it because most stars are born in pairs or in triplets. And around these young stars, you have disks of material of like gas and dust, mostly dust, that didn't make it into the star, but still contracted when the gas cloud collapsed. And that disk is called a protoplanetary disk. Over time, as that material orbits around the young star, it will start to collide with other material, other little specks of dust. Then you'll have these little pebbles, these little rocks. We call these, as they get bigger, planetesimals.
Yes, these are the rocks I'm talking about.
Yes, you said you were right. You were so right. So the planetesimals have sizes of like 10 to like 100 miles across, and eventually those planetesimals will collide to form protoplanets, which are almost the size of planets, and then you get the planets. Mm-hmm. Moons can form during that same process. They can form in a disk of debris that forms outside of a newly formed planet. There are a lot of ways that we think moons can form. But for a long time, it was an open debate about how our own moon formed. And now we think we know the answer.
Yeah, it's a megastructure, I believe. That
I thought you didn't like that word, Corinne. I thought you didn't want to hear it anymore. And here you are, bringing it into this episode.
Here I am bringing it up. You just need a little break sometimes.
You're right. Just a brief reprieve from the megastructures. So I'm not going to give the answer away right now. I actually am going to first tell you a bit about the moon and its properties. And then I'll tell you the different hypotheses that scientists have had. And I'll tell you what we now know about the moon. And then I want you to guess, Corinne, which of the processes actually happened.
Okay,
we're going to do a little detective work, and I think we're going to have a good time. But here are some things that we know about the moon as we can see it and observe it from our little pale blue dot. The moon is roughly a quarter the size of the Earth, and please know that there's, for me, a very important distinction between size and mass. When I say size, I'm talking about like the length of it, the diameter of it. So it has roughly 1/4 the diameter of Earth, which makes it proportionally, compared to the planet that it orbits, the biggest moon in the solar system. There are other moons that are bigger than our moon, but compared to the size of their planets, they are much smaller. Oh. So scientists saw this and they're like, what's up? Why is our moon so big compared to the Earth? Even though it's 1/4 of the size of the Earth, it's only about 1% the mass of the Earth. So it is, on average, much less dense than our planet. And gravity on the moon is lower. It's about 1/6 the strength of gravity here on Earth.
I want to jump on that.
Me too.
I want to see what it's like.
Have you seen those videos of the astronauts?
Falling?
I'm guessing. Oh, I was going to say, like, bouncing around.
I'm like, when they make a fool of themselves.
Well, they're always doing that. No, it's like there's the normal video of them bouncing around the moon because it's hard to walk. Michael Jackson's version of the moonwalk, so inaccurate. But it is really hard to walk on the moon because of the low gravity. So you end up bouncing from place to place. And some comedic genius took that video of the astronauts bouncing, sped it up, and put it to like funny music.
Oh my
so it's
gosh.
just like they're just hopping around.
I haven't seen. I'm dying to see this though.
Okay, I'll you can look it up, or I'll send it to you later.
Yeah.
But you do need to see this video. So gravity is weaker on the moon. The moon is about 250,000 miles away from us. It doesn't have a perfectly circular orbit, so that's an average. And remember, as we've said before, the moon is moving away from us about 1.5 inches every single year. So that is just an average. You could fit about 30 Earths between Earth and the moon.
Whoa.
Or you may have heard that you can fit all of the planets between the Earth and the moon, and it would be a tight squeeze. You would have to get rid of Saturn's rings, but like you could do it.
Oh,
line
okay.
all of the planets up between Earth and the moon.
Whoa.
Yeah,
But then we wouldn't be able to see the moon anymore.
yes,
That
would be the biggest consequence.
That is the only reason we're not doing it right now.
Oh my God. The, Moonfall did get the concept of tidal interactions between the Earth and the moon correct.
Yes.
I can't, like, the gravitational disruption from having all of
That
the
is very
planets
scary.
aligned, so scary.
I don't like that at all.
I imagine that would tear Earth apart if we actually took all the
Yeah.
planets and put them between us and the moon.
Well, I'm out. I'm out before I find out,
Yeah.
but good luck to everyone
Yeah.
else who sticks around.
Good luck. Luckily, that's just not going to happen.
No.
You know, that this is a fun thought experiment. Physically impossible.
Nothing to worry about.
Nothing to worry about. The moon, one of my favorite facts about the moon, whenever people ask me, hey, Moiya, you're an astronomer, do you have any fun facts about space? One of my go-tos is that the moon is tidally locked to the Earth. Have you heard the term tidally locked before?
I don't think so.
Oh, this is really fun. It doesn't just happen to moons. It can also happen to planets and their stars. But basically, when the moon is tidally locked to us, it means that one side of the moon is always facing us.
That I do know.
Yes.
Yeah.
Yeah. So there is a near side of the moon. There is a far side of the moon. There is no dark side of the moon. Another thing that people usually get wrong about the moon being tidally locked is that they think that means the moon doesn't rotate. That's false. Remember, we've talked before about the difference between rotation and revolution. Rotation is spinning on an axis. Revolution is orbiting around a central point. The moon revolves around us, the Earth, and that the length of that revolution is the same as the length of its rotation. So like a day on the moon as it spins is the same length as a month as the moon goes around the Earth.
Oh, wow. Okay.
And that's just like early on, after the moon formed, it was much closer to the Earth, so it was experiencing more of a gravitational pull to Earth. And tidal locking happens when you have these extreme gravitational environments, and it is like an energetically favorable state for the moon to be in, for it to be locked in resonance with the Earth in this way. So it's just like how the energy balanced out early on.
Cool.
We think Mercury might be tidally locked to the sun, maybe. Pluto and its moon, Charon, are tidally locked to each other. So, like the moon sees all the faces of Earth, even though we only see one of its faces. But Pluto and Charon, they're just the same parts of them.
Facing each other the whole time.
Facing each other.
It feels like kind of like a battle with somebody where you're like, I'm not going to turn my back to you. Like you just kind of rotate.
Oh, yeah, that's one way to look at it, a battle. I thought that they were like kissing.
Yeah, you're definitely thinking
You're
of it in
dancing.
a much happier way than I am.
I am. You're right.
I'm like, why? What are the reasons I would never put my back to someone?
Obviously, we're having a battle to the death. The moon has a small but solid iron core and some liquid layers around that. So it has a core, it has a mantle, and then it has a very thin crust. And this is something that I did not know before today, Corinne. So I'm learning right with you for this podcast. On the near side of the moon, the crust is about 45 miles thick, which is pretty thin. It's much thinner than the crust on Earth. But on the other side, on the far side of the moon, the crust is much thicker. It's like almost twice as thick, like 90 miles. And that is because the far side of the moon since it wasn't facing Earth after the moon formed, wasn't experiencing the heat from the very young molten Earth. So it was allowed to cool quicker and solidify faster, and now it's thicker.
Whoa.
And this has a bunch of cool consequences. Like you'll see a lot more craters on the far side of the moon than on the near side of the moon, in part because it's facing away from us, so it's easier for things to hit that side. But also because the crust is thicker over there, the volcanic activity that the moon used to have wasn't as effective at filling in the impact craters. On the near side of the moon, the volcanic activity was easily able to fill in the impact craters, so it smoothed out the near side.
Oh, cool.
Let's see. Yeah, so I talked about volcanoes. The moon used to have active volcanism. It doesn't anymore, and we think that that stopped in the last, 100 million years or so. And temperatures on the moon, as it passes in and out of the sun, can range anywhere from minus 280 degrees Fahrenheit
Oh, gosh.
up to 260 degrees Fahrenheit when it's in
Whoa.
direct sunlight.
That is very cold and very hot.
Yes, it has these extreme temperature swings, in part because it doesn't have an atmosphere or
Right.
much of an atmosphere to help it regulate and distribute heat across the surface. Those are some things we know about the moon.
Aw. I love the moon, and I continue to love the moon.
Yay! Yes, the moon. It's for the people. All right, so now I'll tell you the different hypotheses people had for how the moon formed.
Yes.
These hypotheses they came out in the last century, over the course of the 20th century. And these are the serious hypotheses. There were some that were pretty ridiculous. But the first of the serious hypotheses is called the fission hypothesis. Fission is the opposite of fusion. So fusion is when things come together. Fission is when things pull apart. And essentially the fission hypothesis says that early on in Earth's formation, when it was, still a bunch of planetesimals colliding in the sun's protoplanetary disk, it was very hot. It was molten. Like all of those collisions, all of those impacts, it increases the temperature. So you had molten rock forming this sphere that would eventually become Earth. And the fission hypothesis says that while the Earth was still molten, for some reason, maybe it was spinning too quickly, a blob of that molten Earth separated from the Earth and became the moon.
Okay. Yep. I don't know about that one, but that is making me think of a lava lamp again.
Yes.
Where it just kind of, well, this is so embarrassing, but I put on a lava lamp video the other day. I'm just sitting on my couch watching the lava lamp for, way less time. The video's 9 hours and I watched 2 minutes. But
okay.
It was really fun to watch when the little pieces would break off of the big piece. This is how I try to relax.
That's nice. For 2 minutes.
I don't think it worked. It didn't. Exactly. I gave up immediately. I'm like, you know what? This is boring. I'd rather be
give
worked
it a longer
up.
try.
Yeah, I think so.
Yeah, so fission hypothesis, otherwise known as that thing that lava lamps sometimes do, was one of the hypotheses. The next one was the capture hypothesis. And this said that the Earth formed from that same process of colliding planetesimals, and the moon also formed separately in a different part of the solar system, maybe nearby, through this collection of even smaller rocks and pebbles. And then because the Earth had a stronger gravitational field as a much more massive body, since it was a planet and not a moon, just snatched the moon right up. The moon was passing by, and the Earth's gravity just yoinked it and was like,
it.
"You're mine now.
Interesting.
I'm going to hold on to you forever."
I feel like if that were true, wouldn't we have a lot more moons?
Mayhaps.
Ooh. I'm like, if we're that sticky, I feel like there would be more.
It's the sticky hypothesis. Yeah. I like that you're already in detective mode, thinking about which of these fits with your understanding of how the solar system works.
The listeners can't see, but I've asked the waitress for a magnifying glass, and I'm holding it up.
You are just to the air.
Yeah.
You're not actually looking at anything.
I'm holding
through
it to the moon, Moiya.
Oh, we're inside, Corinne.
Well,
Of course.
the general direction.
Yeah, it's still working. It's doing something for you. The next hypothesis was the co-creation hypothesis, or the co-formation hypothesis, which says that the Earth formed from that same process, and the moon formed by a very similar process of smaller things colliding, but they just happened to happen right next to each other. They just formed at the same time, right next to each other.
Yeah, I'm not really one for coincidences. Or maybe I am. I don't know. Depends on my mood. But that feels like, I don't know. The universe is so big, though. Those random things are going to happen at some point.
Right. They are going to happen at some point, that's for sure. And we're not talking about like the whole universe. We're talking about the solar system, which is a much more local region. So it's more probable that this could happen on these scales. And then the fourth hypothesis that people gave serious consideration to was the giant impact hypothesis, which says that sometime while the Earth was not quite molten but still very young, another object about the size of Mars impacted the Earth. So it hit the Earth and knocked off, the whole Earth would have been like moltenized. It would have combined with this Mars-sized object, and then a chunk would have been knocked off, and the moon would have formed from that chunk. Some people say that first the stuff that was knocked off in the collision would form a disk or a ring around the Earth, and then the moon formed from that ring. Others say that no, it just like it came off and it formed the spherical moon in one fell swoop. Yes, those are it. Those are the four. Those are the four hypotheses.
Interesting.
Are you leaning towards any one over the other?
Well, okay, so with the giant impact theory.
Hypothesis.
There's
a difference.
If the Earth is like softer, molten, like I guess more malleable in that way, like it wouldn't have left like a hole or like a crater or whatever. Okay. So I can't use that as a clue.
No. Although people in the past who considered this hypothesis believed that there was this big crater in the Pacific Ocean that they said was the spot of the impact.
Was the spot.
But you know, like now scientists looking at the giant impact theory have decided that it would have been so powerful to as basically melt the planet.
Yeah. I think it's co-creation is my gut.
Okay. I love that. Why?
I don't know. I think I want it to be giant impact because I like that the kind of storyline of maybe it's like the Reformed Catholic in me who's like, with the rib of Adam, we formed the moon.
Yeah. You're right. Oh, the moon is just the Eve to the Earth's Adam.
And I do think of the moon as me, an extension of me. I do think I come from the moon.
Yes.
So I think that's what I want it to be from like a fantasy storytelling side, but I don't think that's what happened.
All right. Okay. Well, now I'm going to share with you the information we have about the moon that we learned after these hypotheses were come up with.
Okay.
So like we knew this information starting after we went to the moon in 1969. So that 1969 Apollo 11 mission that put humans on the moon for the first time also let them bring samples back. So we could study the actual moon rocks and the composition of them and like the molecular and chemical makeup of these moon rocks for the first time. So the Apollo astronauts, they brought moon rocks back, and we noticed two things. One was that the chemical composition of these moon rocks was extremely similar to the chemical composition of Earth rocks.
Ooh.
Now, we are all in one solar system, so we all have the stuff that like goes into our sun, but you still see different chemical compositions in planets at different distances from the sun. So like the chemical composition of Mars is different than the chemical composition of Venus. It's going to be different than the chemical composition of Pluto because you find different elements and different molecules at different distances from the sun. So knowing that the chemical composition of the moon is very similar to that of the Earth, would you like to eliminate any of these hypotheses?
Well, I can eliminate capture.
Yeah, you can.
I can.
You want to walk us through that logic?
So capture, like I said, like the stickiness of like this thing formed nearby and then got caught in our gravitational pull, but wouldn't have happened if we're kind of made of the same stuff. Well, I guess co-creation too.
That does make it tricky.
Yeah.
But it's still, I'd say it knocks it down a peg, but not totally out of the running.
Yeah, it's not a strike through yet. Or maybe ever. We'll see.
Yes, so that's one piece of information. The other piece of information that we now had when the Apollo astronauts came back said that there were fewer, and I'm using air quotes here, volatile compounds in the moon rock samples than you find in Earth. And these volatile compounds are elements like potassium and zinc and sodium that we usually expect to see as solids, but they can be vaporized at extremely high temperatures, the type of temperatures that you can achieve during extremely energetic collisions. And so it's expected that the moon maybe had these compounds at one point, but that they were vaporized when the temperature got really high. So does that make you think of any other, that you can eliminate any other ideas?
That makes me think of fission, because I imagine it was very hot when that happened.
But the thing is, the fission hypothesis says that the moon was just this blob that came off of the already molten Earth. So it would have experienced the high temperature at the same time.
Right. So I guess I can cancel fission out.
We can cancel fission. Yes.
Goodbye.
And what does this tell you about co-creation?
I don't know. That it might be true?
Well, so this volatile compound thing essentially tells you that the surface of the moon was baked.
Right.
That either like while or after it formed, there were a lot of very high temperatures. Do you think that would have happened during the co-formation process?
I don't know. I feel like my gut does not work in space, if that makes sense. So like,
you haven't developed your intuition yet. That's fine. So the co-formation mechanism wouldn't have this same effect of burning off these volatile compounds, because the Earth and the moon would have formed without any giant impacts.
Okay.
So they would have formed through their small collisions, but then they would have been able to cool down, and both of them would have had similar levels of these volatile compounds. So what we learned by studying the moon rocks was that the Earth, basically the moon underwent an extra baking process that the Earth did not undergo.
Interesting. You got to put it back in the oven for a few more minutes.
Yeah, exactly. The Earth is underbaked.
Yeah, the Earth's a little underbaked.
As they would say on the Great British Bake Off, the Earth has a soggy bottom. You should have left it in the oven just a few more minutes. Or maybe the moon is just overbaked. I don't know what consistency we're going for here.
Yeah, maybe we overdid it on the moon.
So that does leave just one of these hypotheses, and that is the giant impact hypothesis.
Giant impact, the one that I liked the most.
I like that you liked it the most, but you thought that the real answer was a different one. That makes me so happy, because now you know that the one you liked is what scientists think happened.
I love that.
Yeah. Hello, it's me, Dr. Moiya, here to give a shout out to our patrons who are supporting Pale Blue Pod and keeping it going. It really means so much to me, to Corinne, and to everyone who helps make this show over at Multitude. So thank you, as always, to our sun-like stars, Sharn Llewellyn, Finn, Ian Williams, and Megan Moon. You're all just the best. Thank you so much. And thank you to our latest pre-main sequence stars, Young Coconut and Active Galactic Ari. Oh my God, it's like you were meant to be a supporter of this podcast with that name. I am so thrilled to say that we've finally reached our first goal of having 50 patrons. So 3 of them have been randomly selected, thanks to Python's random number generator, to receive a free signed copy of my book, The Milky Way, an Autobiography of Our Galaxy. So congratulations to Ileana Lado, Jessica Elise, and Emma Farrell. You all have messages in your inbox from me. Just let me know where to send the book, and you will have a copy in your hands soon. You can support us, hear your name on this pod, and make it to our patron star chart, all by supporting us on Patreon for just about $1 an episode. You can find all of this info on our website, palebluepod.com, or Just go straight to the source and join our community at patreon.com/palebluepod.
Okay, if you're loving Pale Blue Pod, and especially if you're loving Dr. Moiya McTier, you must give her other podcast, Exolore, a listen. And if you didn't know, Moiya is also a folklorist. So if you've wondered about what life would be like on different planets or how writers create your favorite fictional worlds, Moiya has the facts for you. On Exolore, Dr. Moiya McTier explores fictional worlds by building them with a panel of expert guests, interviewing professional world builders, and reviewing the merits of worlds that have already been built. You'll learn. You'll laugh, and you'll get an appreciation for how special our planet Earth really is. So subscribe today by searching Exolore in your podcast app or by going to exolorepod.com. Do you want to learn more about science, math, AI technology? Just go to brilliant.org. Whatever level you're at, Brilliant will help you master the skills you need. Brilliant is the best way to learn things like math and computer science interactively. There are thousands of lessons from foundational and advanced math to AI, data science, and more. And new lessons are added monthly. Even as a copywriter, I really need to know the ways to stay ahead as this industry is affected by things like AI. The skills I learned to build my career aren't exactly the ones I need now, and this is where Brilliant.org comes in. I'm a big believer in hands-on learning. I know that's how my brain works best, and Brilliant's visual, hands-on approach is such an effective way to master the key concepts behind today's technology. Plus, it's perfect for busy people, with bite-sized lessons that break down important concepts into understandable parts, kind of like Pale Blue Pod. Try everything Brilliant has to offer for free for a full 30 days just by visiting brilliant.org/palebluepod or click on the link in our description. The first 200 signups will also get 20% off Brilliant's annual premium subscription. Again, that's brilliant.org/palebluepod.
So that Mars-sized object that would have hit Earth early in its formation, scientists have called it Theia, Theia, that's probably what happened. I read a paper earlier, and it will be in this episode's research notes, that tries to answer the question of, did Theia and this impact create a ring around the Earth that then coalesced into the moon, or was the moon produced just immediately after that impact? This has been an open question because understanding that the moon formed because of a giant impact still left some mystery about the moon's tilted orbit. The plane of the moon's orbit is about 5 degrees off of Earth's orbital plane, which is a little weird, and it didn't super answer questions about the moon's thin crust. So this paper that I found had a pretty sensational title, but it was these scientists saying that the ring thing probably didn't happen. The moon probably formed right after this impact. They said that it could have happened within hours, which would be wild.
Whoa, that's so fast.
It's so fast. In space? Things that fast
especially
don't
in
really
space
happen.
when things are billion years down the road.
Yes. So they did some very impressive and high computationally powered simulations of lots of particles that would have been moving around during that giant impact. And what they came up with was that if you have the moon just forming very quickly after the impact, then it explains the tilt of its orbital plane. It explains this thin crust. It also explains why you have a thin crust on one side and a thick crust on the other, because these processes happened so quickly. It cooled down so quickly that you have these, I want to say anisotropies, which is just jargon for it looks different on different parts of the moon. My scientist jargon training came back and just took hold over my body, and I couldn't think of any other words.
I saw that. Your eyes rolled back.
They did. They were like, oh, what is English? That's our moon, and that's how our moon formed. But there are dozens. There are over 100 moons in our solar system that we have found. And some of them may have formed through a giant impact. Many of them probably formed through co-creation. Many of them also could have formed through capture. So it's impossible to know without going to those moons and studying their surfaces and their rocks, and also studying the planets that they orbit. But there is a pretty beautiful diversity of planet formation processes represented in our solar system.
Aww.
I really like. Do you know, true or false, every planet in our solar system has at least one moon?
False.
That is false. Yes, Mercury and Venus don't have any moons, and that's likely because the sun's gravity, since they're the closest to the sun, yoinked some of their moons away, or like just didn't let them form moons in the first place. It could also be because of some photoevaporation, which is when you have extremely high temperatures and a lot of radiation that like destroys small particles so that they can't gather together. You do know that the big planets in the outer solar system have like a shit ton of moons, right?
They have tons of moons. I do know that.
So many moons. And I think we just found like a dozen more moons around one of the Jovian planets. Like we just discovered 12 new Uranus moons or something. We're finding new moons all the time. But giant planets, at least in our solar system, and we're still studying to see if this holds true in other stellar systems, giant planets have dozens of moons. And that's mostly because their strong gravity makes it really easy to hold on to the moons that have formed through any of these processes. It also makes it easier to capture moons that form elsewhere. So they're greedy. The giant planets, they're moon greedy.
They're sticky.
Yes. Rings. Earth doesn't have rings, but other planets in the solar system, like Saturn and Uranus, they have rings. It's expected that Mars in the future might have rings, and that it might have had rings in the past too.
Ooh.
Mm-hmm. Is that news to you? Like that was surprising to me.
That I did know because Mars was like a big part of the Space Center stuff we did. So I have a bigger working knowledge of Mars. Oh, also I did like a Mars themed summer camp. I forgot. Not through the Space Center, through this other tech company. So yeah, I have a much greater knowledge of Mars than I do of anything else.
Interesting.
But like more in like the rover. Yeah, like more in the rover aspect.
Maybe we can do an episode where you teach me about the Mars rovers.
Oh my gosh, I should. I had so many little slides from my camp days.
Let's do that. I love a slide. So there are multiple planets in our solar system that have rings. These rings usually form, they can form just by a planet accreting lots of small pebbles, things that aren't even planetesimal size. And if it gathers through gravity enough small pebbles, then they will start to orbit and eventually they will fill out all the space and it will become a ring. But you can also form these rings around planets by tearing apart other things like moons, which means that out in space there is this beautiful cycle of making moons and destroying them through gravity so that you make a ring, and then out of that ring moons form because the stuff in the ring collides. It's just this thing just happen over and over again. And scientists think that might be what's happening with Mars's moon Phobos. They say that in the next 50 million years or so, Mars could rip Phobos apart through gravitational interactions, through tidal interactions, very similar to what they talked about in Moonfall, and that a ring would form from that. But they looked into the history of Phobos, and we still need to send stuff to Phobos to study its composition. But this might be one instance of that cycle of making a moon and then destroying it to make rings and then putting it together to make a moon, back and forth, which is beautiful. Saturn's rings are mostly ice, which does not necessarily mean water ice. It's ice of other elements like methane and ethane ice. And they likely formed in the last 100 million years. Scientists for a while thought that Saturn's rings were quite old, but then once we sent the Cassini spacecraft to study the rings and the individual ice particles that make them up, we saw that they're a lot brighter than we would expect if they were old. Old things in space undergo a weathering process that will turn them darker. This happens with the moon often. And essentially they realized that Saturn's rings are too bright to be old. They haven't undergone much weathering. So in the last 100 million years or so, and that ring material is being pulled in by Saturn's gravity. So Saturn might eat its own rings.
Yeah. So what would happen if that's happening? Like it gets closer and closer to this atmosphere and surface of Saturn?
Saturn. Yeah. It just gets absorbed in. But Saturn does have a moon called Enceladus that is sending out geysers of water and other icy particles. So it's kind of replenishing at least one of Saturn's rings.
Drama.
I know, right? Love that interplay. And this has all been in our solar system, the rings and moons in our solar system. But we can also start thinking about moons around exoplanets and rings around exoplanets. My advisor in grad school, his name is David Kipping. His name is David Kipping. He's not dead. He just got a cat. Very adorable. He had a reputation in astronomy as being the guy who works on kind of, I'm not going to say wacky because they're all very reasonable, but he had a reputation for pursuing projects that seemed like they wouldn't be doable for a very long time, because he was one of the pioneers in the search for exomoons, the moons around other planets. He started doing this work in 2006, 2007, I think was the first time he published a paper on exomoons, and they still have not found an exomoon.
Whoa.
There is no confirmed exomoon that scientists have discovered. They have candidates.
Yeah.
And he and another grad student in my program, he was a grad student at the time, Alex Tichy, he's now a postdoc in Taiwan.
He did astronaut training once, my show.
Yes,
he did.
he did.
With you on the first ever one, maybe.
Probably.
Maybe.
That
I was like,
tracks.
I know I follow Alex TJ on Twitter, and it's definitely because he did my show.
So David and Alex found the first exomoon candidate, Kepler 1625b, which is the planet orbiting Kepler 1625, the star, and then that planet would have a moon around it, they think.
Cool.
But it's really hard. It's hard enough to find planets around stars. It is nearly impossible to find moons around those planets around other stars. Yeah. And so one of the most common ways to search for exomoons is to look at the transit light curves of planets as they orbit their stars. And we're going to talk more about this in next week's episode when we talk about the detection methods for exoplanets. But essentially, you are measuring the amount of light you get from a system. If a planet passes in front of the star, it will block that. So if you're graphing the light over time, you see a dip in the light curve. And if there is a moon around one of those planets and it's orbiting the planet as the planet orbits the star, then you would see a tiny little trace of that in the signal. It could be that as the planet is just starting to pass in front of the star, like it's coming over its, we call it the limb or the outer edge of the star. If the moon is going around it, the moon at some point will be in front of the planet. So it will pass in front of the star first. And so you get this tiny little dip, and then the moon goes behind the planet, so the dip goes away. And then the planet goes in front of the star, so you get the bigger dip. So they can study that little double dip feature in the light curve to look for moons. They can also study these two different phenomena. One is called a transit timing variation. The other is called a transit duration variation, or TTVs and TDVs. It's a lot easier to read than it is to say out loud.
I'm seeing it in the notes, and I'm like, that's a tongue twister for sure.
But both of these just they're based on the premise that the moon would tug a little bit on the planet, just like planets can tug on stars. We talked about that in the redshift episode with radial velocity. And so if they're really precise about measuring when a planet transit starts and stops and how long the transit lasts, and there's any sort of deviation from what they expect, that's a sign that something is tugging on the planet like a massive moon.
Cool.
So like I said, we have found a few candidates for exomoons, but none of them have been confirmed, although I like to think that we're going to find one soon. And also we know they have to be out there.
Yeah.
Because the physics of our solar system it's not special.
Yeah.
It's the same elsewhere. So we would expect that if we see moons in our solar system, other planets have them too.
Yeah,
It's just a matter of powerful enough telescopes.
There's so many in our solar system that it's hard to imagine. It's impossible that there wouldn't be anymore.
So that's all I have on moons and rings and exomoons. Do you have any questions or thoughts before we move on to Moonfall.
Well, I'm sure you'll keep me updated for the rest of our lives, but if we find out where the moon definitely came from, I gotta know.
Okay, yeah. We are pretty sure. The giant impact hypothesis has kind of turned into the giant impact theory. It is definitely the most accepted explanation. So Moonfall.
Moonfall.
Definitely go back, if you haven't, and listen to our episode where we review Moonfall. But if you have already listened to it, then you'll remember that one of our big peeves with this movie was the fact that they kept talking about extra mass. That the moon all of a sudden had more mass than we thought it did. There's this scene where Casey Houseman
Yes.
is talking to people at NASA about the impending moonfall, and he says, we're dealing with a megastructure here, so your rules of gravity don't apply anymore. And I was so mad at that line, but I think that as I've noodled over it since, and as I've tried to be extremely generous and open-minded, I think I know what Casey was trying to say.
What?
So if the moon were a natural satellite, if it was just a rock that formed in space, then we would be able to measure its mass based on its orbit around the Earth. That's just math. But if it's a megastructure, and we did see that it's capable of maneuvering itself, because as soon as the main characters take the bad aliens out of the megastructure moon, the moon tries to go back to its normal orbit. Which means that since it's a megastructure and not a natural satellite, it can, I don't know, use like thrusters or whatever to put itself in whatever orbit it decides to be in.
Yes.
Which means that its mass doesn't determine where it orbits.
Yeah.
So I think that what Casey was saying is this is a megastructure. It can move on its own, which means your rules of gravity and the way that you have determined its mass, they don't apply anymore because the moon can move.
I love that you're thinking of this. I think you're giving them a lot of credit.
I'm trying. I like to be kind to people who I know put a lot of effort into.
I'm coming in with like, this is what I hated. And Moiya's like, here are some things that were great.
I did have a lot of thieves for that movie. Yeah, definitely more peeves. But yeah, it's been bugging me because I know one of the science advisors who worked on that movie. Mika McKinnon is a geophysicist and a disaster researcher. She's consulted with shows like Stargate on their science. And I just know that she's so smart. I didn't think that she would let them get away with that.
Yeah.
So it's really been bothering me, and I needed to share this.
You needed to prove it.
Yeah.
Also, that movie is so funny because I would bet that any science advisor could come in and they'd still be like, well, this worked for the plot, so we're going to keep it.
Oh, yeah. That is the curse of the science advisor. You can advise, but they don't have to listen to you.
No.
And I figured, maybe it was one of those situations where Mika was like, no, you can't just throw out the rules of gravity. And then the directors were like, well, screw you. It works for the story. But no, I think that this might be what they were trying to do.
I think you did solve it.
Thank you.
And I'm glad you did.
That's where the extra mass came from.
Okay, well, speaking of Moonfall.
Okay, I'm ready.
I have a little fun game for us, which is I have a series of quotes in front of me that I'm going to read to you. Some of them are real quotes that were said on the moon, and some of them are not.
On the actual moon?
Yes.
In real life, not in fiction.
In real life, not in fiction. And some of them are not. So, Moiya, I want you to use your detective skills, and you can use my magnifying glass if you need.
Okay, thank you.
To guess if this was something that was actually said on the moon or if it wasn't.
All right, I'm ready.
Okay, here's the first one. Quote, "The surface is fine and powdery. I can pick it up loosely with my toe."
With your toe? No astronaut has ever been on the moon with their toes out. They wear these really heavy boots, so I'm going to say that's false.
It is real.
Whoa.
I tricked you.
Who's out here using their toes like they're on a beach?
That is from Neil Armstrong from the Apollo 11 transcripts, which I did Google for this game.
Wow.
And are out there. And you know what? They're not that fun. I'm trying to get gossip or something, and it's just like science.
Yeah, they knew they were being recorded. They weren't saying anything juicy.
No. Okay, here's another one. Quote, I can see my house from here.
They can't see their house.
No.
That's false. That's false,
That
Corinne.
is false. That one is
Okay.
from ChatGPT. I asked the AI copywriting software to tell me what an astronaut would say on the moon, and that's what it came up with, so I'm out of a job.
Huh. Yeah. Oh. I have a lot of strong feelings about ChatGPT. So let's move on.
Okay, next one. Quote, it has a stark beauty all its own. It's like much of the high desert of the United States.
Ooh. I feel like you might be tricking me again, but that sounds totally plausible, so I'm going to say true.
It is. That's also Neil Armstrong from the transcripts.
Oh, was no one else talking?
Yeah, really no, because there's even a part of the transcript where President Nixon calls them and is like, this is the most historic phone call of all time. And I think just Neil spoke back to him. It was just like one of the astronauts spoke and they were both like on the call, and I was like, you both can talk. I mean, I don't know the protocols, whatever.
I guess maybe Buzz was a man of few words.
Yeah, I would bet. Okay, next quote. I think you're going to know this one. Quote, you're telling me that the moon was effectively the biggest cover-up in human history?
Is that from Moonfall?
That's from Moonfall. That one is from Moonfall.
Oh, you didn't want to use the one about the moon being full of produce?
I almost did, but I was like, that one's like so obviously Moonfall.
Yeah.
Okay.
What a gem.
Next one. I don't know, lad. It's like no cheese I've ever tasted.
Okay, so I don't know, lad means that they're talking to someone.
True.
And the astronauts on the moon, they would not have called each other lad. That would be very disrespectful for people of their status.
Yeah.
So I'm going to say that this is false.
You got it right. That is correct. That is a quote from Wallace and Gromit, the 1989... Well, it's from A Grand Day Out, but it's the 1989 Wallace and Gromit movie that I loved as a kid.
Oh, nice. I've never seen it.
It's like claymation, and they like go on an adventure, and it's fun.
Nice. I miss claymation.
Me too. I love it. There's a few... Sometimes it comes up in my TikTok, like some like indie animators are doing a thing, and that's always fun. Okay, let's do two more.
Okay.
Quote, didn't I say we might see some purple rocks?
You know, I like the idea of purple rocks on the moon, so just for that, I'm gonna say true.
You're right. That was Buzz Aldrin.
He spoke!
He does speak.
Good for him. There are purple rocks on the moon?
That's, according to the transcript, that's what they said. A lot of the transcript is like describing the moon to mission control.
I like that it's, I told you there would be purple rocks. Like
Didn't I say,
he knew ahead of time.
Yeah, he was like, I've been telling you the whole ride we were going to see purple rocks.
Oh, Buzz.
Okay, last one. It's highly likely our moon was built by aliens. We have to get inside and make first contact.
Are you fucking kidding me?
This is a tricky one.
I am stumped. I have no idea what is going to be. No, no one said that on the moon.
No one said that on the moon. That was also Moonfall.
Thank you for letting me flex my detective
Yeah, you're
muscles.
really good at that. I'm going to have to trick you harder next time. Although
I trained under Sherlock Holmes.
I trained under Psych. Did you ever watch that show?
Oh, I loved Psych.
I loved Psych. It's on Peacock now if you want to watch it again.
Oh, nice. It was like the young person's Monk.
Yes, exactly.
When it came out.
And I also watched Monk, so it was nice to feel both. Like mature, I'm watching Monk, and cool and hip, I'm watching Psych.
Yes. Approach from both angles. Corinne, I think that I see them bringing out our pasta dishes. They must have like made the pasta from scratch back there because it's
sure
been a while.
Did. Someone's grandma's back there making this.
Oh, I love a good like Nona pasta.
Exactly.
You know?
It's different than others.
But remember, no matter what you put in your red sauce, you are still made of space.
You are space. And so is that red sauce.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.